and then we'll work on an old IB exam. I think I have the one from last year. We'll do that the other days in class till the end of the semester. Sound good to you guys?
This class is our first one.
Yeah, I think the first day after school ends is this exam for you guys.
It's the last day of school.
I think it's the last.
Oh, it's the last day of school.
Last day of school.
We're missing other classes.
Okay.
Wait, when's our exam?
I think it's May 1st.
So I'm gonna have to sit there.
Is there 2 parts? They're crazy.
Yes, it's 2 parts.
May 1st and May 2nd.
So do we have to come in another
It's
day? Wait, we have Spanish.
I believe so.
It's at
Alexis has the sheet.
1 to 3:30 on May 1st, but it's only an hour and a half long, so I don't really know how that works. And then 9 to 11:30 on May 2nd.
Let's put that in the announcements.
It's an hour and a half long. 1 to 3:30. Well, I don't know if that means we're going to stay until 2:30. No, our test line. But that's the allotted time. So, I think.
Okay, hold on. 5-1. What's the time?
1 to 3.
And what's the location?
Media Center class.
And then 5-2 is
5-2 is 9 to 11:30.
Okay, so the time period for the test, the window they gave you was like 3 hours or something. The test is only an hour and a half in length each day. My suspicion is because they have like multiple IB exams in that window. Some of the other exams might run longer than yours. So my suspicion would be that they'd let you go as you, like, after your hour and a half is finished or whatever. There may be some pre-registration stuff that needs to get done the first day that drags things along a little bit, where like you have to fill out your name and your school information, all that mumbo jumbo or something. I don't really know. I've never sat through that part of it. And we'll talk about some calculator stuff that we need to make sure that we do before we start the exam, but we'll do that after we do the practice stuff.
Also, what is AI structured and
so there's the course, instead of like, there's 2 versions of SL. So there's like A&I and then there's A&A. We all are A&I. The other version is like A&A. I don't know enough anymore about that, the details of like what the differences are, but I don't think our school offers any A&A courses. I don't know enough. If you have Miss Sagert later today, you could ask her, and she would assuredly be able to tell you all the details.
I already talked to you. Need to go talk to her about the album. So. I just need to be presence today.
Okay. That would be the person that, if you have IB exam, like what the heck does this mean? Like A&A or A&I, unstructured, whatever. Like ask Miss Sagert. You could ask her about the time window even and be like, how long am I really going to be here for? And I'm sure she'd be able to give you a good answer to that.
I just thought like on the last day of school, like I could like.
So today, my plan is to finish chapter 11. These will be the last 2 sections of new material we're going to do for the semester, for the your high school mathematics career, would be my plan. Your last 2 homework assignments are the one for this Sunday, 11-1 and 11-2, and then the following Sunday, 11-3 and 11-4. This will be the last 2 homework assignments. Keep in mind, I am dropping 2 low homework scores. So if you have 100% in all the homeworks up to this point, not completing anything won't change your grade. If you do have some less than 100% homework scores, you may still want to complete these last 2 assignments if you're on the borderline between one grade and another. Everybody's okay? Would it help if I just put zeros in for those right now so you can just see worst case scenario what everything looks like?
No. Are you still dropping the quiz or did you already do that?
It's already automatically been done. So the low quiz score has automatically been dropped.
Let's go.
So I think that's all set. Let me double check. I guess that's worth double checking. Yes, 2 homeworks are being dropped right now. Do you want me to put zeros in for those last 2 just to see?
I have a question.
Yeah, what's up, Diggs?
There's an assignment a while back that he gave me a 50% on because the PowerPoint wasn't uploaded yet, and so I couldn't do that part of the homework. Yeah.
Okay.
Could you
You want me to go back in time and fix this thing?
Yeah, could you please do that?
Probably not right this second, but if you talk to me after class, we can figure it out, okay?
Just remember that.
So this is what happened last time. You said I'll figure it out later. You forgot it just now.
Sorry about that.
It was his fault.
Okay, I'm like, I don't know. I'm usually pretty good about trying to go back and, okay. Okay. Are we ready to get this party started?
Yeah.
All right.
You're like, should I ask him now?
Stats was my big.
All right. So in 11.3, we're going to be like, I've hinted at this idea already, that somehow the integral is equivalent to area under the curve. We're going to kind of explore that idea right now. So we're going to start with just some examples. So we're given some functions. We're going to sketch the function and then shade the area between the curve and the x-axis for the given interval. And then we're going to use geometry to find the shaded area. And then we're going to calculate the value of the integral of the function for the same interval. All right. So A is f of x equals 3. What does f of x equals 3 look like? Not vertical, horizontal line. And we're interested in what's happening from 1 to 5. So there's our graph of our shaded region. What's the area of that shaded region? What shape is that? Rectangle. Great. So what's the area formula for rectangle? Length times width. So let's call this guy the width and this guy the length. So what is it going to be? 5 times 3. No, it's not 5. Who said that? Isaac. It's only 4 units there, right? 1, 2, 3, 4. Ah, I gotcha. So far, so good. Part C then says calculate the value of the definite integral. So we'll do the integral from 1 to 5 of 3 dx. What's the antiderivative of 3? There you go, 3x. And we need to look at that from 5 to 1, or 1 to 5. So what did we get there? What's the takeaway? They're the same. Yay. So what you'll likely see on your IB exam are problems where you're given only a graph and not any function definition and asked to calculate the integral. The way we would do that is looking at the area under the curve. We end up using geometry to calculate that area. All right, part B, how do I graph g of x equals 2x? What's that going to look like? Like a line, yeah. So like something like that, right? So 0, 1, 2, 3. I'm not going enough up. Yeep. Better do this in a different color. Yes. Okay. What shape do we have here? Triangle. What's the area formula for a triangle? Okay. So this is like my base. And this guy's like my height. What's the base? It's 1, 2, 3. And what's the height going to be? 1, 2, 3, 4, 5, 6. So it's 9. Because you didn't count from 0 to 1. Here we're going from 0 to, right? Okay, so what's the antiderivative for 2x? We add 1 to the exponent and then divide by the new exponent, right? And shockingly, I'm just so shocked and surprised. It was the same answer. Oh, Mr. Kulik, you got to be joking. So crazy. Who's playing Stickman? Who would play Stickman in class? You know? That's so disrespectful. 1, 2, 3, 4, 5. Yeep. Try to do a little better than that, Kulik. Okay. So -1, 0, 1. So my next function was y equals -x plus 5. So there's my graph. What shape is that? Trapezoid is correct. What's the area formula for a trapezoid? It's the average of the two bases times the height. So that's B1, that's B2, and that's my height. So far, so good? Okay. So 1/2 6 plus 4 times 2. So we get 10. Our integral okay, what's the antiderivative of negative x squared? Or, I'm sorry, of negative x. Or the antiderivative of negative x is negative x squared over 2. Again, I add 1 to the exponent and divide by the new exponent.
Wouldn't that go from negative 1x to 0? Well, it's then oh, it's the x.
Because that's to the first, right? And what's the antiderivative of 5?
5x.
Yeah. So what do we have here? We have 5.5 minus, and then I have a negative here, so that's plus a half, and then a negative there, so that's plus 5. Oh, shoot. That's negative a half up there, so that's 4.5. And I get 10 again. So far, so good. Our last function, this is a doozy, guys, is the square root of 4 minus x squared. What's that shape going to look like? You're both wrong. Diego's closer to a right answer than Isaac was. Nope. Where is this function going to equal 0? How about at 2? And negative 2. Okay, what will be the value at 0? Zero squared is 0. 4 minus 0 is 4. Square root of 4 is 2. We should be able to do that in our heads here, folks. What do you see? That's a half a circle. So the area should be 1/2 area for a circle, pi r squared. What's the radius in this case? It's 2. The diameter is 4. Ah! I'm off today. Now, how do I do the antiderivative of 4 minus x squared? How do you do that? You don't! You don't know the antiderivative rules to be able to do that. What should you do?
Calculator.
Use your calculator. So I did math and then command 9. So I get that. Fn int is the name. And what is, that's not 2 pi, is it?
It is.
It is. Yeah. It is. What's the drawback of having to use the calculator? You're not going to get it in terms of pi, but it's all right. Yes, sir. Okay, let's do another example. So it says, in this example, it says the graph of f of x equals yada, 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 given in figure 110, that's, or 1110, that's this. Find the area enclosed by the curve and the x-axis. So I know that that area is going to be the integral of f of x dx, but I need to figure out what the bounds of that integration are. What are the bounds of that integral going to be? It's going to be those spots right there where it intersects the curve, or intersects the x-axis, right? So I need to find those. How do I find those? You could graph it on your calculator and find the x-intercepts. Algebraically, though, we should be able to do that relatively easily. What is the y value when we're on the x-axis? 0. So I can just say negative x squared plus 2x plus 3 equals 0. I would multiply both sides by a negative 1 so that my leading coefficient is 1. And then that factors pretty easily. So I'm just going to do the integral from negative 1 to 3. How am I going to do that integral? On my calculator. On the IB exam, you get your calculator the entire time. All questions are calculator questions. Don't do anything by hand. Write down what you're typing into your calculator and then just type it in your calculator. Don't do anything by hand. In particular in these calculus sections. Like your calculator can do all of these integrals and derivatives and everything for you. Don't do it by hand. Just show the setup and type that crap into your calculator and say, thank you very much. My teacher trained me well on how to use my calculator. Is everybody okay? So I get 10.7 units. Or thereabouts. Everybody cool? Big deal, little deal, no deal? I don't think it's a big deal, right? It's all right. Here's a more interesting question. Let's say instead of looking at the area between the curve and the x-axis, what if we want the area between two curves? So let's say we have f of x equals root 3, or root of x plus 3, and then g of x equals negative 2 x minus 2 cubed. First thing I would do is I would graph the two curves to look at the picture. So we're looking at the area between these two curves and the x-axis. I guess they may not intersect 2 times or whatever. Let's see what it looks like here. Okay. And then I'll just zoom standard that. I don't remember where I was at last, but that's probably a decent window. Okay. So it looks like, let's go from like -4 to 3 or something and get a little bit better picture here. And we can dump off most of that stuff below and a lot of that stuff above. It's probably enough there. Okay. So that's my picture. Ah, darn it. Just trying to minimize this so I can have the calculator out while I draw the picture for us. I absolutely hate this new Windows that's like, oh, you touched the top of the screen, you must want to maximize this. It's like, no, I know how to press the maximize button. Stop like making this harder for me than it needs to be. You know what I mean, guys? Do you hate that? Yeah. Drives me freaking nuts. Anyways, that's my soapbox.
I'll let him know we get on.
You guys are just rough on poor Isaac here. He deserves it. Okay. I think Gavin actually said he deserves it.
No, that was
oh, that was Diego. Well, never mind. I retract my statement.
I think Gavin's rubbing off on it.
All right. So if I want, this is asking me now for the area between the two curves and the x-axis. So I'm looking for this spot in here, right? Guess what I can do? Watch this stuff. So if I look at that boundary right there, left of it, that's just the integral of f of x, right? And to the right of it, that's just going to be the integral of g of x. Everybody agree with that? So all I need to do now is fill in the two bounds for each of these integrals. So if I look at that first integral, I need to find this point, and then I need that point. I need the x values at those. Well, that first one's easy, right? Look at the curve f of x equals root x plus 3. What is the x value there at the x-intercept? -3. How am I going to find that second point, though? Yeah, I'm going to use the intersect command on my calculator. I'm not ever going to do anything by hand on the IB exam because I get my calculator the whole time. That turns out that's the 0.12. So there's 1. If I look at my second integral, what does the lower bound have to be? 1. It starts where the other one left off. And where then I need this value here. Where is g of x equal to 0? You should be able to look at that and tell. At 2, right? 2 minus 2 is 0. 0 squared is 0. 0 times -2 is still 0. You could also do it on your calculator. right? You could just do the x-intercept or the 0 command on the graph, right? You could get it that way also, no big deal. But that's the idea. Once I have that, guess what I'm doing? Now I can just type these integrals into my calculator, right? What's Will doing out there? I don't know anything about baseball. I don't know anything about TikTok. So it's like a double black hole for me. Matthew?
We have the best sports.
The dancing? Bro, I was just talking to Will about it.
We heard. So that's 5.83. I heard Yo Will out in the hallway.
Me and Will are like pretty much dating at this point.
Oh, that's great for you guys. I'm happy you found someone. Which Will? Would you say it's a will he or won't he relationship? That's a pun. It's definitely a will be. This is fun. I love puns. All right, last example for this section, then we can keep it moving. A ramp for skateboarding is a side piece that is modeled by the area enclosed by the y-axis, the x-axis, and the function f of x is equal to 1, and the curve g of x equals yada, yada, yada. Use your GDC. What does GDC stand for again? Yeah, Graphing Display Calculator. It just means your calculator. To sketch the shape of the side piece on a coordinate plane using the equations above. That's irritating. Because it's like, I don't really need to do that, but like, all right. I'm not really going to be using my calculator to do this, just FYI. I'm just going to use like my head and my brains. So f of x equals 1, I'm going to say is here. And then this curve I know has a 0 at 3, because if I put a 3 in here, that goes to 0. Square root of 9 is 3, and 3 minus 3 is 0. So that's going to look like this. Is everybody okay? Actually, let's do a different color, right? That's prettier. So it looks like that. All right, so that's part A. And again, I could type that into my calculator, right? Like, you know, you got y equals 1. And then the other one is all this mumbo jumbo. Right, I just elected not to because I could look at it with my eyeballs and tell what the thing was going to look like. But should you do that on the IB exam?
No.
No, don't use your eyeballs. Use your calculator. Everybody's okay? All right. It then says find the coordinates of the intersection of f and g. Well, I can see it's at 1, 1, but I don't do that on the IB exam. I use my calculator to do that. So intersection, enter, enter, enter. Okay, enter, enter, enter. Oh my God. Ah! Oh, wasn't 1, 1. Sheepers creepers, I almost made a catastrophic mistake. Now I gotta go back and find my spot. So that's 0.76 4, comma 1. And then it says find the area of this thing. So if I'm going to find this area, I have that rectangle and this kind of like ramp piece, right? So let's find the area of this rectangle first. Everybody's good there? And we'll find the area of that remaining piece. Everybody's good with that? And then it's just calculator time, my homies. Is this too bad? This should feel pretty easy, right? Not too bad, though. Maybe not pretty easy, but like, this is not complicated stuff. Because we've stripped away all the complicating parts and just asked you to like, can you do this procedure? Which I fundamentally kind of disagree with this approach as a math teacher, but like, it is the course that I'm teaching, so. So I got about 1.45, and it would be meters cubed because it's a volume.
I'm telling you, everything gets more. The race part gets more.
Bro, you go vroom vroom, you won't be bored.
No, dude, that's why you get a truck to go
Were you bored?
Yeah. It's unreliable, bro. You have no idea.
This is so dumb. All right. A last section.
It's just a lot. Did you play on the weekend before?
Go kart.
Did we play Monday? That's insane. I could not do that. I cannot do that.
All right. We're so close, guys. Just hang in there for me. So the last section, we're going to be talking about approximating areas under the curve, which seems like a really backwards way to do this, rather than teaching the integral first and then the approximation second. But it is what it is. So the idea here, let's say we have this table of data where this is like x, and this represents an f of x. So these are just like x, y's. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And then 1, 2, 3, oh, let's go, no, 2, 4, 6, 8, So if I plot these points, I have 0, 12, and then I have 2, 17, and then I have 4, 18, then I have 6, 16, and then I have 8, 15. So what we're going to do is we're just going to kind of assume that the function is linear in between the points. Okay with that? So to approximate the area under the curve, I'm going to divide this into 4 trapezoids. Everybody can kind of see that? So 1/2. So this is going to be base 1 and base 2. And then the distance here is going to be my height. That's my first trapezoid. For my second trapezoid, these would be my bases. And that distance would be my height. For my third trapezoid, those would be my bases. And that distance would be my height. And on the fourth trapezoid, those would be my bases, and that distance would be my height. Everybody okay there? And then it's just calculator time, right? Here's the good news. Look at this. Boom, 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 boom. Those all kind of canceled out. That's pretty cool. So I have 29 plus 35 plus 34 plus 31. And that all comes out to be something, let me do that, 129. Now, would you do that in your head on the IB exam? No, type that stuff in your calculator and press enter, right? All right, let's do another example. FYI, from a vocab standpoint, what we just did there was using a trapezoidal rule, is what that's called, because the shapes we made were trapezoids. It appears that's the only type of approximation the IB uses. In AP Calculus, we'll do right-hand rectangles, left-hand rectangles, midpoint rectangles, do lots of different rectangles, which is more appropriate since the limit definition of an integral is rectangular based as opposed to trapezoidal, but whatever. Okay, a medical test for diabetes measures glucose concentration in a patient's bloodstream to determine the patient's glucose tolerance by calculating the total area under the curve in some unit there. I can't really, milligram, I don't know what H is. Is that hecto? No, I don't know what the H is. Whatever. Yeah, I don't know. It's some kind of over deciliters, I'm assuming the DL is, or deciliters. Yeah, I don't know. Anyways, after a patient is given a glucose solution, the following data points are measured. The first thing I'm going to notice here is that the distance between the time slice, or the x values, is constant, right? It's always a half a unit. Everybody see that? So I know I'm going to be doing a rectangle, or I'm sorry, trapezoids. So I'm going to do 1/2, and then I'm going to have the height, and the height is the same for all the trapezoids. So I'm just going to put that out front. Is that okay with you guys? Rather than writing it over and over and over and over again every single time. And then I'll just have my sum of my bases. Now the height in this case is also 1/2. So I have just 1/4 times that sum. And this all comes out to, when I type in my calculator, about 241. And I guess we need MGHDL minus 1, whatever the unit, whatever that, I don't care. Some unit. Okay. We're going to do, what I got? A couple more examples. And we're just going to be done here. Can you guys hang in there for 3 more examples? Yeah, hold on tight. This is completely wrong. These guys are a bunch of bozos. I have to say, like, I've read a lot of math textbooks in my day. This one for this class is so terribly edited. It is riddled with mistakes. Like, I've not gone through a section where I haven't found, like, no one read this. No one reread this. You didn't issue this to any teachers and let them read this and be like, and try to use it in class, be like, that's a mistake. That's a mistake. Like, it's just clearly wrong. Like here they're trying to say, so they say using trapeziums 0.8 units wide. So if we're going from 0 to 8, how many trapeziums would we need? 10. You know what their answer uses? 5. They go from 0 to 4. It's clearly typoed. It should be the integral from 0 to 4 for their work to be correct. They didn't catch it. Nobody caught it, apparently. It's absurd. As a math teacher, I'm like really offended every time I catch one of these things. I'm like, who edited this? Who edited this book? Like, I get that there occasionally are answers that are like stuff that slips through, and that stuff, if it's in the answer keys, like I can deal with. But this is like an example problem. Somebody should have read this and like clearly caught that that's like really wrong. It's not just like a little wrong, it makes no sense wrong. So I'm going to change this to 4 because like 10 trapezium is like so stupid. Okay. So our x values, I go from 0 to 0.8, and then I go 0.8 to 1.6, and then I'm going to go 1.6 to 2.4, and 2.4 to 3.2, and then last one is going from 3.2 to 4. So again, my areas, I should say approximately, is going to be 1/2 times the height. The height is constant. It's all 0.8. The first pair is f of 0 plus f of 0.8, where this is my f of x. Everybody's okay there? Actually, I don't even need to put a parenthesis. The next one is going to be f of 0.8 plus f of 1.6. And then f of 1.6 plus f of 2.4. And then f of 2.4 plus f of 3.2. And then f of 3.2 plus f of 4. What do you notice in here? We got some like terms that we could combine. Now, if I'm showing my work, I'd much rather just skip right to this thing, right? What's the pattern? It's 2 of everything except for the first and last, right? So again, the way I would type this into my calculator is I am not doing anything by hand. So I'm going to type in this function here into y1. How do I get those absolute value bars on there? Math, number, and then ABS is the first option. Then I'll do 2 to the x, and then minus 8. And then back on the home screen, I'll do 1/2 times 0.8 times parenthesis vars y vars function y1 of 0 plus vars y vars function y1 of 0.8. Oops, I meant 2 times plus 2 times vars y vars function y1 of 1.6 plus 2 times vars y vars function y1 of 2.4 plus 2 times vars y vars function y1 3.2 plus just 1 times vars y vars function y1 of 4. I get about 18.1. Is everybody okay there? Yeah, it's kind of a pain, but it is what it is. No, you can't store that as a different variable or something, because you can only store numerical values. You can't store an equation. Typing it into y1 is storing it. I don't know if there's a faster shortcut to get the y1 to show up. If this were like an AP calculus class, we'd show you how to use like summation to do this, but it's kind of not worth it because the summation is enough. Like manipulate. None of these you're going to have like 20 of them to where the summation like manipulation you'd have to do to make it work is worth not just brute.
It's still easier to do it by hand. You know?
Yeah, yeah. All right. Let's make this one our last example. Yay. Sure.
Always.
Okay. It says, given that y is equal to f of x, it says write down an expression using a trapezoidal rule to estimate the area under the curve from 1 to 3 with intervals that are 0.5 units wide. So our intervals, we're going from 1 to 1.5, from 1.5 to 2, from 2 to 2.5, and then from 2.5 to 3. Everybody agree with that? So my area is about 1/2 times the height times the quantity, f of 1 plus 2 times f of 1.5, f of 2, f of 2.5, and then f of 3. You could write 2's in front of each of those, but I'm like, I just did it with a quantity because it's felt like it was going to be less writing, although now that I look at it, I used 3 symbols to do that. If I just wrote 2's in front of them, that's still 3 symbols, so there's really no compactness that I gained there. Oh well. Part B says the value A is equal to the area under the curve f of x equals x squared plus 1. When estimated using the trapezoidal rule, find the value of A to 4 significant figures. So here's the good news, Diego. If I change this to x squared plus 1, and I take that previous thing I typed in, I can just lightly edit this to work. So the 0.8 should be 0.5. Y of 0 should be 1. Y of the first y is 1.5. And then I have 2. And then I have 2.5. And then I don't want this guy. And that should be a 3. So I get 1075. Is that okay? You like how I did that? Where I just used the previous line, lightly edited it. There's a lot less menus to jump through. Oh, that was part B. Part C says the value of B is equal to the area under the curve, yada, yada, yada. Write down the definite integral and then use the calculator to get it. Okay? So this is the definite integral from 1 to 3 of x squared plus 1 dx. Well, to get that value, math command 9, 1 to 3, x squared plus 1 dx. So 10.67. And then it says find the percentage error. So our error percentage is estimate minus actual divided by actual times 100, right? Which one is the estimate, the 1075 or the 1067? Nope. The 1075 is the estimate. So if I grind that through on my calculator, I get 0.75%. Or 0.750, I guess. It's significant figures. What do you guys say? You say whatever, man. I was done like 3 days ago.